Hello students, welcome to lecture number 4 in design and analysis of algorithms. Okay. In the last lecture, we have seen how to measure the time complexity of an algorithm through step count method, right? Okay. In this lecture, we will see how to measure the time complexity of an algorithm through the second method which is available in your syllabus is operation count. So in the last class, we have seen step count method, right? So how step count method will going to be works? The step count method will measure the time complexity of an algorithm based on the number of steps which are available in the algorithm, right? Now coming to the operation count, okay. So the theme of operation count is available in the name itself. So what is this method name? Operation count, okay. So it will count the number of operations which are available in the algorithm. So that's why this concept is named as operation count, okay. So to measure the time complexity of an algorithm by this method, first of all you need to identify what are the operations which are available. So based on the number of operations which are available in your algorithm, you can have a capability to get the total time complexity, okay. Now let us observe how this method will going to be works, okay. So this is your unit 1 syllabus. So in the unit 1 syllabus, in the last classes, we have completed definition of an algorithm, algorithm specifications, recursive algorithm, and we have seen how to measure the time complexity of an algorithm in the step count method. And in the current class also, we are going to be discuss about analysis part, how to measure the time complexity of an algorithm with the help of operation count. Okay. So in this lecture, we are going to be discussing about the definition of operation count method and how it is going to be works, as well as what are the rules which are required to apply algorithm, as well as we will see some examples, so that you will get the clarity how this method is going to be works. Okay. So the main objective is you will get an idea how to get the time complexity of an algorithm, and main outcome of this lecture is you will analyze the time complexity of an algorithm with the help of this operation count method, right? So what is our method name? Operation count, okay. So as I said previously, it will count the number of operations which are available in the algorithm with a count variable, okay. Through count variable only, I can have a capability to get the time complexity. Now immediately you will get a doubt like, what is the value that can be available in this count variable, okay. So initially this count variable is initialized with 0. So the count variable will going to be incremented for each execution of your statement, okay. So the final value that is available in the count variable will be considered as a total time complexity, right. Now we try to focus on how the definition is going to be. Okay. So as I said previously, so instead of finding the number of steps in step count method, in the operation count method, we are going to be count the number of operations, okay, through a count variable. So initially the count variable is initializing with 0, okay, and it is going to be incremented for each execution of the statement, as I said previously. Okay, and the total value that is available in your count variable will be considered as a total time complexity. Okay. Now let us discuss an example how this method is going to be works to get the time complexity of a corresponding algorithm. Okay. Now, so we will see an example on sum of elements which are available in the array. This algorithm is very known to you. Why? Because this algorithm we have discussed in the step count method itself. Now you try to observe whether this operation count method also will going to be produces the same output or not, okay. So both methods, nothing but your step count method as well as operation count method, will having same equal power. Both the methods will produce the same result, but the way of approach to solve the time complexity or to get the time complexity is going to be different, okay. So that is the difference you need to understand, okay. Now we try to focus on what is the algorithm is going to be, okay. So if you observe here, so this algorithm is going to be accepting 2 parameters as an input. So first parameter is an array and second parameter is the size of the array. So initially my sum is 0 and you need to trace all the n elements which are available in the array. So that's why I have taken a for loop. So this for loop will trace the elements which are starting from 1 to n, okay. So for every iteration I can have a capability to get the corresponding index element, and in that element I am going to be performing my addition operation, so that I can have a capability to update my S value. So after complete execution of this for loop, I am returning my result. Okay, so that is the main theme of this algorithm. Okay, this one is very known to you. Why? Because we have solved this algorithm time complexity in previous method, which is step count. Now we try to observe whether operation count also going to be produces the same output or not, right? Now we try to observe the algorithm. So this is going to be your algorithm. Now we try to focus on and you try to find out how many operations which are available in this algorithm. So if you observe very very carefully, okay, so the first operation, what is your first statement which is available in the algorithm? S equal to 0. Okay, so what is the operation of this statement? Simply a assignment operation. This is your operation number 1. And what about the second operation? In the after performing initialization operation or assignment operation, you are having a for loop. Okay, for the loops, you are going to have two types of operations. For loops only. So what are those? Are entering into the for loop is first operation, the control coming out of from the loop is second operation. Okay, so the control which for every iteration, the control will come enter into the for loop to execute the statements which are available in the loop or not. Yes, so entering the for loop is one operation, and coming out of the for loop is another operation. Okay, as of now you got 3 operations, and the fourth operation is performing a arithmetic addition operation, and the fifth operation is returning the result. So this algorithm is having how many operations are there? Total 5 operations. So you required 5 count variables initialized with 0. So based on the number of times your statement is executing, that number of times only the count variable is going to be increments. Now you try to observe how the count variable you are declaring for the corresponding operation, and how the count variable is updating to get the total time complexity. And as I said previously, you required first count variable for assignment operation, and you required second count variable for loop, okay, and third count variable for the statements which are available in the for loop to perform this arithmetic addition operation, and the fourth count variable you required for the control to come out of from the for loop, and fifth count variable you required to return the result S. So likewise, total you required 5 count variables for this algorithm. Now initially, what is the value that can be available in this count variable? 0, right? Now we try to focus on how to update the count variable. Now you tell me how many number of times the first count variable is incrementing? How many number of times you are initializing S? Only one time, right? So the value that is available in the count variable is going to be 1. Now coming to the second count variable, how many number of times the control will go inside the for loop? So it depends upon the upper bound of your for loop, right? So what is the upper bound of this for loop? N. So how many number of times the second count variable is going to be increments? N number of times. Okay. Now coming to the third count variable. So how many number of times this arithmetic addition operation you are performing? So this statement is available inside a for loop, right? So ultimately the execution of this arithmetic addition operation will depend upon the upper bound of your for loop. So ultimately the third count variable also will going to be increments n number of times. Now coming to the fourth count variable, how many number of times the control will come out from the for loop? Only one time, right? So for the fourth count variable, the value is 1. Okay. Now coming to the last or the fifth count variable, how many number of times you are returning the result? Only one time, and the count value for the fifth count variable is only 1. Okay. So likewise, you are going to be update the count variable like this. Okay. For the first count variable, the value is 1. For the second count variable, the value is n. For the third count variable also, the value is n. And for the fourth count variable, the value is 1. Why? Because the control is coming out of from the for loop only one time, right? And coming to the fifth count variable is also only 1. You are returning the result only one time. So likewise, you are going to be have a updated count variables. Now we try to sum all these count variables. Okay. So how many count variables are there? Total 5 count variables are there, right? Now we try to sum all the values which are available in these 5 count variables. So here n is available, here n is available. N plus n is 2n. How many ones are there? total 3 ones are there. So 1 plus 1 plus 1, which is going to be 3. So the sum of the total time complexity of this algorithm based on the count variable is going to be 2n plus 3. So I hope you are aware about the same algorithm we have applied in the previous concept, which is step count. So in that method also we got the same result, right? So as I said previously, the step count method or the operation count method, both will produce the same result, but the way of approach is different. Now we try to focus on the second example. So you are aware about the matrix addition, right? So in the matrix addition, how many parameters you are taking as an input? 5 parameters you are taking as an input. Okay, so the first 2 parameters will be considered as an input arrays, and the third parameter will be considered as an output array, and m and n will defines the dimension of your input and output matrix. M defines number of rows and n defines number of columns. So likewise, to trace the number of rows as well as number of columns, you require 2 for loops. So inside your 2 for loops, you are going to have a arithmetic addition operation to apply on a matrix. Okay, so the elements which are available in the A as well as the elements which are available in the B will going to be performed. You are going to be apply a matrix addition operation, and the result you are storing into C. Okay, so likewise you are going to be have this algorithm. Now you try to focus on how to introduce or how to declare the count variables as well as how many count variables you require based on the number of operations, and we try to focus on how to update these count variables. Okay. Now can you tell me how many count variables you required? First count variable for you required for first for loop. Okay. Second count variable you required for second count variable you required for second for loop. Okay. And the third count variable you required for the statement which is available inside these 2 for loops. And fourth count variable you required for the control which is coming out from the inner for loop, and fifth count variable you required for the control which is come out from the outer for loop. Okay. So before having the discussion, so here I am declaring for I equal to 1 to 3 and inner for loop for j equal to 1 to 2. Okay. Now you tell me how many number of times this inner for loop is executing? The inner for loop is executing depend upon the outer for loop upper bound value, right? So what is the upper bound value that is available in the outer for loop, which is going to be 3. Okay. So the control will enter into the inner for loop how many number of times? 3 number of times. Okay. And the statements which are available inside these 2 for loops will going to be execute how many number of times? Outer for loop will execute 3 number of times, inner for loop will execute 2 number of times. So the total number of times the statements which are available inside this example is going to be 6. Okay. So this is the way you are going to be trace the 2 for loops. One for loop is available inside another for loop. Okay. So now we try to focus on how to declare the count variables for the corresponding operations which are available in this algorithm. Right. Now you require a first count variable for outer for loop, and you require second count variable for inner for loop, and you require the third count variable for the arithmetic addition operation, and you require fourth count variable for the control which is coming out from the inner for loop, and you require the last count variable which is the fifth count variable for the control which is coming out from the outer for loop. Now you try to focus on how to update the count these 5 count variables. So initially all these count variables are initialized with 0, right? Now how many number of times the outer for loop, the first count variable is updating? M number of times. Okay. Now how many number of times the inner for loop is executing? N number of times. And the execution of inner for loop will depend upon the outer for loop or not? Yes. So the inner for loop will going to be executing n number of times, and the execution of the inner for loop will depending upon the upper bound of your outer for loop or not. So together the count value is mn. Okay. So n number of times the inner for loop is executing. The execution of inner for loop will depending upon the outer for loop execution. Together it is mn. If these 2 for loops are available separately, then you will going to be get separate values. But if there is a dependency between the loops, ultimately you need to carry. So that is the thing you need to remember. Okay. Now you tell me what is the value that is going to be available in the third count variable. Okay. How many number of times this statement is executing? So ultimately the statements which are available inside these two for loop will depending upon the upper bound of outer for loop as well as upper bound of inner for loop or not. Yes. So the value that is going to be available in the third count variable is mn. Okay. So as I said previously in the previous example of your for I equal to 1 2 3 as well as j equal to 1 2 2. Now you tell me how to update the fourth count variable. Okay. How many number of times this fourth count variable is associated to the inner for loop or not? Yes. Now how many number of times the control is coming out of from the inner for loop? It depends upon the upper bound of outer for loop. Okay. So the execution of inner for loop will depending upon the upper bound of outer for loop. Right. So in that way the value that is going to be updated to your fourth count variable is m. Why? Because the execution, how many number of times you are entering inside to the inner for loop? M number of times. Okay. And how many number of times the control will come out? Only one time. Now for the last count variable the value is going to be becomes 1. So likewise you try to sum all the values that are available in these 5 count variables, so you will get the total time complexity. Okay. Now coming to the third one, linear search. Okay. So for this linear search, how many parameters you required as an input? 3 parameters you required. So first parameter defines array, second one defines size of the array, and third one defines key. Okay. So to trace all the elements, to verify the key which is available in the array, you require a for loop. Okay. And the logic that is going to be available inside the for loop is, here you are verifying whether the corresponding element which is available in the array which is equal to your key variable or not. If it is available, you are returning true, otherwise returning -1. Okay. So what is the logic that is available in the algorithm? If else. If else. So if the condition is true, ultimately the control will execute if block statements. What happens if condition has been failed? The control will entering into the else block to execute the else block statements. Okay. So if the condition has been failed, ultimately the values for these statements are going to be becomes 0. Okay. If condition is true, and the values for the statements which are available inside else block are going to be becomes 0. Okay. So likewise you need to trace the algorithm if you are having if else. Okay. Now you try to observe. So okay, how many count variables you required? You required first count variable for the for loop, and second count variable for the if condition, and third count variable for the return statement. Okay. And you required fourth count variable for the return -1 statement, and you required the last fifth count variable for the control to come out from the for loop. Okay. So for the loops, entering is one operation, coming out from the loop is another operation. So likewise you are going to be have 5 count variables which are required to this algorithm. Now we try to focus on how to update these values. Okay. So how many number of times the for loop is executing? N number of times, and the value that is going to be available in the first count variable is n. Okay. Now coming to the second count variable, how many number of times you are verifying the corresponding index array element to your key? N number of times. The value that is going to be available inside the second count variable is n. Now coming to the third count variable, how many number of times you are returning the result? Only one time. Now coming to the fourth count variable, how many number of times you are returning the statement, you are returning the value return -1? Only one time. And how many number of times the control is coming out from the for loop? Only one time. Okay. Now we try to find out the time complexity for both cases if element is equal to key as well as not equal to key. So you will get the total time complexity for this algorithm is 2 n's are there, and here 1 n is there. A of I equal to key, here you are returning 1 as well as you need to consider this one. If A of I not equal to key, ultimately you need to consider this one and the last one. So ultimately the total time complexity of this algorithm is going to be 2n plus 2 for both cases if key has found as well as key not found. Okay. Now coming to the fourth example, which is going to be the recursive sum. Okay. So this algorithm is very known to you, and this algorithm is going to be performing a addition operation on the elements which are available in the array in a recursive way. Okay. So if n is less than or equal to 0, you are returning 0. Otherwise you are going to have a recursive call to reduce the n parameter with n minus 1. For every iteration or for every function invocation, you are retrieving the corresponding array index value. Okay. So now you try to focus on how to introduce the count variables for every operation that are available in this algorithm. Okay. And you required first count variable for if condition, and you required second count variable for return 0, and you required third count variable for else block statement, which is going to be the recursive. Okay. Now you try to focus on how to update these values. How many number of times you are verifying the n value? Only one time, and the value that is going to be updated to the first count variable is 1. And how many number of times you are returning the result, which is going to be 0? Only one time. Now coming to the third count variable, how many, for every function invocation, how many values you are retrieving? For every function invocation at a time, how many values you are retrieving? Only one value. And for every iteration of your for loop, how many function invocation are going to be happened? For every function invocation, your n is reducing to n minus 1. That means only one function invocation will be there, and for every function invocation, only one element you are retrieving. Okay. Now you try to observe how to update the third count variable value. Okay. The third count variable value is going to be 1 plus recursive sum of n minus 1 only. Why? Because n is reduced as n minus 1. And what about 1 here? At a time you are retrieving only one element from the array. And what about n minus 1? Why? Because n is reducing to n minus 1 for every function invocation. So that is the main theme of this algorithm, how to update the count variables. Now we try to focus on the total time complexity. So 1 plus 1 is 2. So that's why here the time complexity is 2 plus recursive sum of with a parameter n minus 1. Now how to try to focus on how to get the time complexity for the second case, which is going to be 2 plus recursive sum of n minus 1. You try to expand this equation to get the total time complexity. Okay. So if you observe this expansion, so ultimately you are going to be have for the second case, the n parameter value will be reduced as n minus 1. So this is going to be a total time complexity. If you observe the RHS part, what is a new problem to you? N minus 1. Now we try to apply the substitution method to get the value of the n minus 1 value. So if you call this RHS part for the second time, ultimately wherever you are having n, you are simply replacing it as n minus 1. So this will be going to be 2 plus recursive sum of n minus 1 minus 1. So n minus 1 becomes n minus 2. So likewise you are going to be updating the substitution method third time. So after applying these number of times, your equation is going to be converted in an expansive way. In a n terms, it looks like 3 of 2 plus recursive sum of n minus 3. Okay, now I am converting this equation in terms of n. So ultimately this is going to be look like n of 2 plus recursive sum of n minus n. What is the value of n minus n? That is going to be become 0. So what is the value if the parameter is equal to 0? What is the value if the parameter is equal to 0? Ultimately the value is 2. Now you try to submit these values. Okay, so after knowing the parameter value with a 0, ultimately you can have a capability to substitute this n value in the first case. The total time complexity of this expansion is going to be n of 2 plus 2. Okay. So as of now we have seen how the operation count method will going to be works, and we have seen how to initialize the count variable and how to update the count variable and how to get the total time complexity with the help of some examples. Right, and try to take this one as an assignment. Try to find out the time complexity with the help of operation count method for the matrix transpose algorithm as well as matrix multiplication algorithm. Now this is going to be your quiz. Try to note down these questions, and we will discuss the solutions for these questions in the class itself. Okay, thank you. That's the end of the class. Thank you.